Hello students, how are you? I am Manoj sir from AP. Today I will discuss coordinate geometry part 2. Yes, so coordinate geometry part 2. Today I will discuss 4 points. The first point is distance between 2 points in the 2D plane. Second point is applications of distance formula. Third point is section formula. And fourth point is midpoint of the distance between 2 points. So these 4 points I will discuss one by one. Now, distance between 2 points in the 2D plane. 2D plane means two-dimensional plane. So here P is a point whose coordinates x1, y1, and Q is another point whose coordinates x2, y2. So we have taken these 2 points on the 2D plane and we have to find the distance between these 2 points. Is it clear? So how I will find and what is the formula, that I will discuss. In this figure, see, since P is the point whose coordinates x1, y1, so from origin to this foot of the perpendicular is how much? x1. Is it clear? Now from origin to this, how much? x2. Why? Because the abscissa part of this point is x2. So how much this length? x2 minus x1. Yes, so this length is x2 minus x1. Similarly, this ordinate length is y1 because the coordinates of P is x1, y1, so ordinate part is y1, that indicates this length of ordinate is y1. Similarly, this length y2 and this length y2 minus y1, that means QT, this length is y2 minus y1. Is it clear? And see here, this is a right angle triangle. Is it clear? It is a right angle triangle. PQT is a right angle triangle. So from this figure we are getting a right angle triangle, yes, like this. This is P and this is Q and this is T. So P, Q and T. And PT we got how much? x2 minus x1. PT is x2 minus x1. So x2 minus x1 and QT is y2 minus y1. And we have to find the length of PQ. Yes. So easily you can find applying Pythagoras theorem. According to Pythagoras theorem, PQ square equal to PT square plus QT square. Yes, PQ square equal to PT square plus QT square according to Pythagoras theorem. So now put the value PT square, that means x2 minus x1 whole square plus QT square, that means y2 minus y1 whole square. Is it clear? So PQ square is this. So what will be PQ? PQ will be root over of x2 minus x1 whole square plus y2 minus y1 whole square. So that means x2 minus x1 means difference of two abscissa. Square of that plus difference of two ordinates and square of that. So PQ length will be obtained using this formula, root over of x2 minus x1 whole square plus y2 minus y1 whole square. Is it clear? So we got the formula for distance between 2 points. Now we'll find a particular case distance between origin and a point x, y. A point whose coordinates x, y. What will be the formula? See here, from origin to this point, length is how much? X. Yes, and this is y, and this is right angle. So again, it is a right angle triangle OPQ. Yes, OPQ is a right angle triangle. Again, we are getting one right angle triangle. This is O, see the figure, and this is P, and this is Q. That means PQ, and we got this length is X and this is Y. So again, applying Pythagoras theorem, OP square equal to OQ square plus PQ square. Yes, so OQ square means X squared and PQ square means Y square. So OP root over of X square plus Y square. Yes, OP is root over of X square plus Y square. So this is the formula for distance between origin and any point whose coordinates X comma Y. I think this part is clear, students. Okay, fine. Now I'll discuss the second point, applications of distance formula. Is it clear? So I have completed the first point. Now I am going to discuss applications of distance formula. Second point. Here many applications. Application 1, for given 3 points A, B, C, to decide whether they are collinear. That means we know the coordinates of 3 points. We have to check the given points are collinear or not. How will check it? First we will find the distance between two consecutive points. Means we will find AB, we will find BC, and we will find AC. Is it clear? Then we will check the sum of the shorter distances equal to the larger distance. Is it clear? If we get this result, that means larger distance equal to the sum of the shorter distances, then we can say the points are collinear. Otherwise they are not collinear. Yes. So take one example. Let A, B, C are 3 points whose coordinates are given. We have to prove these points are collinear. So just now what I told, you have to find AB, BC and AC, 3 sides length. Is it clear? How can you find AB? Using distance formula. AB x2 minus x1 whole square. That means here if I mark, this is x1 and this is y1 and this is x2, this is y2. So x2 minus x1, that means 4 minus 2 whole square plus 7 minus 3 whole square. So what is the result? 4 and 16, because 4 square. So root over 20 is the result. Now we will find BC. Applying same formula, that is distance formula, what is the result? 6 minus 4 whole square plus 11 minus 7 whole square. That means 4 plus 16, that is again root over 20. Now let us find AC. What is the result for AC? 6 minus 2 whole square, 11 minus 3 whole square equals to 6 minus 2 4, that is 16 here, and 8 square, that is 64, and that is root over of 80, and root over of 80 means 2 root over 20. Yes or no? 4 into 20 is 4 into 20 is 80. Yes, 2 into root over 20. We can break it, but see here, root over 20, and it is 2 root over 20. That means it is clear AC, the larger distance, equal to the sum of other two shorter distances. So here AC equal to AB plus BC we are getting, and this result implies A, B, C are collinear. Yes, from this result we can say points are collinear. I think this part is clear, students. Okay, fine. Now application 2. For given 3 points ABC, to decide whether they are vertices of a particular triangle. We know we have various types of triangle: equilateral triangle, scalene triangle, isosceles triangle, right angle triangle, isosceles right angle triangle, various types of triangle. So how we can check for the given 3 points which are the vertices of a triangle the particular type of triangle we have to find out. Is it clear? So how here also we'll find the 3 sides length, say AB, BC, CA. If we see 3 sides lengths are equal, then we can say the triangle is equilateral triangle. If we see 3 sides are unequal to each other, then we will say it is a scalene triangle. If we see 2 sides are equal, only 2 sides are equal, then we can say it is an isosceles triangle. And for right angle triangle, the largest side square equal to the sum of the square of other 2 sides. That is Pythagoras theorem satisfy, then we can say the triangle is right angle triangle. Yes, and if we see the triangle is right angle triangle along with 2 sides equal, then we can say it is an isosceles right angle triangle. Yes. So now take one example. Example 2 here. Prove that the points ABC are the vertices of an isosceles triangle. So for that we have to find 3 side length. One by one we will find it. AB. Distance formula again. AB means minus half minus 1 whole square. That is minus half minus 1 is minus 3 by 2. And square of that is 9 by 4. Yes. Plus half minus 1. Half minus of minus 1. Be careful. Half minus of minus 1. That is half plus 1. 3 by 2. So 3 by 2 square again it is 9 by 4. Is it clear? That means 3 by 2 into root 2. Yes, because 9 by 4 plus 9 by 4 is 2 into 9 by 4, and square root of 9 by 4 is 3 by 2. So and 2 will be under root. So 3 by 2 root 2 is the AB length. Is it clear? Now we will find BC. What is the length of BC? 1 minus of minus half. That is 1 plus half, that is 3 by 2. So 3 by 2 whole square again 9 by 4 plus 2 minus half, that is 3 by 2, and square of that 9 by 4. So again we are getting 3 by 2 root 2. Now find AC. What is the result for AC? 1 minus 1, that is 0. 0 square is 0, and 2 minus of minus 1, that is plus 1. 2 plus 1 is 3, and 3 square is 9. So 0 plus 9, that means 3 unit. Yes. So what is the observation here? AB and BC equal. AB and BC equal and these are not equal to AC. Yes. So this result implies the triangle is isosceles. Yes, the vertices are the what? Vertices of an isosceles triangle. Is it clear? This implies given points are vertices of an isosceles triangle. Yes, is it clear? Now one more example I'll do, example number 3. So that the points A, B, C are the vertices of a right triangle, that is right angle triangle. Is it clear? So for that, again we'll find AB, BC and AC one by one. So AB result 3 minus of minus 2, that is 3 plus 2, 5. 5 square is 25. Yes. Now minus 4 minus 5. Minus 4 minus 5 is minus 9. And square of that is 81. So finally we are getting root over 106 unit. Now BC will calculate 7 minus 3, that is 4. 4 square is 16 plus 10 minus of minus 4. 10 minus of minus 4 is 10 plus 4, 14. So 14 square is 196. Yes. So it is giving how much? 6, 6, 12 here and 20 plus 1, 21. Yes. So 212. Is it clear? Now we'll find AC. AC is 7 minus of minus 2, that is 7 plus 2, 9. 9 square 81 and 10 minus 5. 10 minus 5 is 5. So 5 square is 25. So this result is given how much? 106. Square root of 106 unit is the length of AC. Now what we have to prove? We have to prove these are the vertices of a right angle triangle. That means the largest side, that is BC here I am saying. So BC square result is how much? 212. And what is the sum of the squares of other two sides? That is AB square plus AC square is giving 106 plus 106, that is 212. So BC square is coming BC square equal to AB square plus AC square, and this result implies the triangle is right angle triangle. Yes. So given points are vertices of a right triangle. Right triangle. Clear? This part is clear? Okay. So now application 3. When 4 points A, B, C, D are given and we have to decide the given points are the vertices of a particular quadrilateral. That means the given points can be the vertices of a parallelogram, can be the vertices of a rhombus, can be the vertices of a square, can be the vertices of a rectangle. So we have to check. Is it clear? How? If we see after finding all sides length, that means AB, BC, CD, AD, and also two diagonals length, that is AC and BD. If we see opposite sides are equal, then we can say the quadrilateral is a parallelogram. Is it clear? But if we see opposite sides are equal and diagonals are equal, then we can say it is a rectangle. Is it clear? Again, if we see all sides are equal, then we can say it is a rhombus. And if we see all sides are equal and diagonals are unequal, then also we can say rhombus. But to prove rhombus, if we show only four sides are equal, then we can say it is a rhombus. But to prove square, all sides are equal and diagonals are equal, that we have to show. Is it clear? This is a very important point. So again I am repeating, to prove parallelogram, just show opposite sides are equal. Diagonals equal or unequal, no need to check. But to prove rectangle, we have to prove opposite sides are equal and diagonals are equal. To prove rhombus, just show opposites, not all sides are equal. Is it clear? Not opposite side, all sides are equal, we have to prove. And for square, all sides are equal and diagonals are equal, that we have to show. Is it clear? So now example number 4. Here 4 points given, ABCD, coordinates also given, and these points are taken in order. Name the type of quadrilateral ABCD and give the reason for your answer. This is the question. So we will find AB. Here AB length is 7 minus 4 3, 3 square is 9, yes, 6 minus 5 1, 1 square is 1, so root over 10. Now find BC. BC means 4 minus 7 minus 3 whole square, that is 9, and 3 minus 6 minus 3 whole square, that is 9, so root over 18. Now we will find CD. CD of 1 minus 4, that is minus 3 whole square 9, plus 2 minus 3, that is minus 1 whole square, that is 1, so root over 10. Now AD. AD how much? 1 minus 4, that is minus 3 whole square, that is 9, and 2 minus 5, that is minus 3 whole square, that is also 9, so root over 18. Is it clear? Now we will find AC, the diagonal. What is the result for AC? 4 minus 4 0, and 3 minus 5 minus 2 whole square, so 0 plus 4, that is 2 unit. And BD result 1 minus 7, that is minus 6 whole square, that 36, plus 2 minus 6, that is minus 4 whole square, that is 16. So 36 plus 16, yes, BD 1 minus 7, that is minus 6 whole square, 36, and 2 minus 6, that is minus 4 whole square, 16. So it is coming root over 52. Is it clear? So what is our observation here? Opposite sides are equal, that means AB and CD equal. Yes. And also BC and AD equal. And diagonals are not equal. This implies the quadrilateral is a parallelogram. Yes. So ABCD is a parallelogram. Is it clear? The quadrilateral is a parallelogram here. Example 4 completed. Now example 5. So that the following points taken in order are the vertices of a square. So we have to prove these are the vertices of a square. For that we will find all sides length and also will find length of diagonals. So AB here, 0 minus 3 whole square, that is 9. 5 minus 2 whole square, that is also 9, because 5 minus 2 is 3, 3 square is 9. So root over 18 unit AB. Now BC. BC minus 3 minus 0, that is minus 3 whole square, 9. 2 minus 5 minus 3, that is whole square is 9. So root over 18. Now CD. Length of CD, 0 minus or minus 3, that is plus 3 whole square, that is 9. And minus 1 minus 2, that is minus 3 whole square, that is also 9. So root over 18. Now we'll find AD. AD is how much? 0 minus 3 whole square, that is 9, and minus 1 minus 2, that is minus 3 whole square, that is also 9. So root over 18. So all sides lengths are equal. Now let us see the diagonal AC. What is the length of AC? Minus 3 minus 3, that is minus 6 whole square, 36, and 2 minus 2, 0 square, that is 0, so 6 unit. And now BD, length of BD, 0 minus 0, that is 0, and minus 1 minus 5 is minus 6, the whole square, that is 36. So 0 plus 36, square root of that 6. So what is your observation here? All sides are equal, that means AB equal to BC equal to CD equal to AD, and also we are seeing diagonals AC and BD, they are also equal. So from here we can say the given vertices, the given points are the vertices of a square. This implies given points are vertices of a square. Is it clear, students? This part is clear? Okay, so example 5 completed. Now I'll discuss section formula. Yes? So this is the third point. I'm going to discuss section formula. What is this? Now here 2 points A and B we have taken, whose coordinates are x1, y1 and x2, y2. So line segment AB joining these 2 points we are getting, and this line segment is divided by another point C whose coordinates I have taken here x, y, and this segment AB is divided at C in the ratio m is to n internally. Then we can find the coordinates of C. What will be the coordinates of C? That will be mx2 plus nx1 upon m plus n, and ordinate part will be my2 plus ny1 upon m plus n. Is it clear? So formula written here also, mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. This is very easy to remember this formula. See here, if you remember the formula like this, say m into x2. Yes, when you are taking part of this ratio here m, and you will take the which is far away, yes, not near, far away, that is mx2 plus nx1. Is clear? Just remember like this. So mx2 plus nx1 upon m plus n, sum of the terms of the ratio. Yes or no? Similarly, same thing we can do for ordinate part. So m into y2 plus n into y1 upon m plus n. So easily we can remember the section formula like this. Is it clear, students? Now I will show the proof of the section formula. Proof of the section formula I will show. Generally, the derivation of this formula in all books it is done by the concept of similarity, but I'll show the proof without using the concept of similarity. Okay, see here, n how much? From origin to A, that is x1, and from origin to n, that is x. So n will be x minus x1. Yes. Now from origin to R is x2, and from origin to n is x. So what will be nr? x2 minus x. Is it clear? Now we'll take the projection of PQ on x-axis. What is the projection of PQ on x-axis? That is AR. Now PQ is divided at m in the ratio m is to n. So projection AR also will be divided at n in the ratio m is to n. Is it clear? So that means we are getting x minus x1 upon x2 minus x equals to m upon n. Is it clear? So this implies mx2 minus mx equals to nx minus nx1. Is it clear? This implies mx plus nx equals to mx2 plus nx1, and this implies m plus n into x equals to mx2 plus nx1, and this implies x equals to mx2 plus nx1 upon m plus n. Is it clear? So we got the x coordinate of the point M. Yes, x coordinate of the point M, which divides PQ in the ratio m is to n. So similarly we can find the y coordinate. So for that we will take the projection of PQ on y axis. So if I draw perpendicular from here on y axis, from M perpendicular on y axis, and from Q I am drawing one perpendicular on y axis. Is it clear? Say name I am giving here, say S, T and U. Now what is OS? OS is Y1 and OT is Y. So TS will be Y minus Y1. Yes. Similarly OU is Y2 and OT is Y. So it will be Y2 minus Y UT. But again, projection of PQ on y axis is SU. So SU will be divided at T in the ratio m is to n. Yes or no? So that means we are getting result what? We are getting result y minus y1 upon y2 minus y equals to m by n. This result implies my2 minus my equals to ny minus ny1. That implies m plus n into y equals to my2 plus ny1, and this result implies y equals to my2 plus ny1 upon m plus n. So that is the y coordinate of the point m, y coordinate of the point m. So finally we got the section formula, that is mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. So we derived this formula without using the concept of similarity. Yes or no? Is it clear? Now I'll show the midpoint formula, midpoint of the distance between 2 points. Here A is a point whose coordinates x1, y1, and P is a point on AB whose coordinates xm, ym, and B is a point x2, y2. Since P is the midpoint of AB, so the ratio will be 1:1. So in the formula, in section formula, if I put m equal to 1 and n equal to 1, then we are getting x1 plus x2 upon 2. Similarly, y1 plus y2 upon 2. So that is the midpoint formula. Yes or no? So this is the midpoint formula. Is it clear? Now I'll solve example number 6. Okay. So midpoint of the distance completed, that is 4 points already finished. Now I'll discuss few sums, that is example number 6. Find the midpoint of the line segment joining the point 2, -6 and 6, -4. Is it clear? So if I draw a line segment AB, say A coordinates of A is 2, -6 and coordinates of B is 6, -4. We have to find the midpoint, coordinates of midpoint. Say P is the midpoint of this segment. Then according to formula, coordinates of P will be what? x1 plus x2 by 2, that is 2 plus 6 upon 2 minus 6 plus of -4 upon 2. That means 8 upon 2, 4, and minus 10 upon 2, -5. So 4, -5 will be the coordinates of midpoint. Okay. Now I will discuss example number 7. Find the coordinates of the point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3:1 internally. So again I am drawing one segment, say AB. Coordinates of A say 4, -3 and coordinates of B given 8, 5. And this segment is divided by a point P in the ratio 3:1. The ratio 3:1. And we have to find the coordinates of P. So what will be the coordinates? Using section formula, we are getting mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n. Is it clear? Here m is 3. 3 into x2, x2 means 8 here. N means 1, so 1 into x1, x1 is 4. upon 3 plus 1. 3 into 5 and 1 into minus 3. Yes, 1 into minus 3 upon 3 plus 1. So this result implies 24 plus 4, 28 upon 4, comma 15 minus 3, because 1 into minus 3 minus 3, that is 12, 12 upon 4, and this implies 7 comma 3. So coordinates of P we got 7 comma 3, which divides the segment in the ratio 3:1. I think this part is clear, students. Okay, fine. Now example number 8. The three vertices of a parallelogram ABCD are given here. Find the fourth vertex D. So if I draw a parallelogram ABCD, say ABCD is a parallelogram. Coordinates of A given 3 comma 4, coordinates of B given 3 comma 8, and coordinates of C given 9 comma 8. We have to find the fourth vertex D. Say coordinates of D x comma y. How can we find it? We know in parallelogram diagonals bisect each other. We know this property. So that means diagonal AC and diagonal BD, diagonal AC and BD intersect with each other at P, suppose. So P is the midpoint of AC, again P is the midpoint of BD. So applying concept of midpoint formula, we can find the coordinates of P. Coordinates of P in respect of AC. In respect of AC, coordinates of P is 9 plus 3 upon 2 and 8 plus 4 upon 2. That is 6 comma 6. Yes. Now coordinates of P in respect of BD. In respect of BD, x plus 3 upon 2 comma y plus 8 upon 2. Yes. But both are coordinates of P. Therefore, x plus 3 upon 2 equal to 6 we can write. Y plus 8 upon 2, that also 6. So from here we are getting x value 12 minus 3 is 9 and y value 12 minus 8 is 4. So that means coordinates of D we are getting 9 comma 4. Yes. But using shortcut trick we can find the coordinates of D easily. How? Coordinates of D will be 3 plus 9 minus 3. So 3 plus 9 12, 12 minus 3 is 9. Similarly for y, 4 plus 8 12, 12 minus 8 is 4. So this technique we can apply to get the coordinates of fourth vertex. Is it clear? Understood? Okay. Now example number 9. The midpoints D, E, F of the sides of a triangle ABC are given here. Find the coordinates of the vertices of the triangle. That means we know the midpoints of three sides of a triangle and we have to find the three vertices of the triangle. Is it clear? Say coordinates of A x1 comma y1, coordinates of B I am taking x2 comma y2, and coordinates of C I am taking x3 comma y3. Midpoint of AB, say D, and its coordinate 3 comma 4, coordinates of E 8 comma 9, and coordinates of F 6 comma 7. Is it clear? So we have to find the vertices of the triangle ABC. Clear? See, x1 plus x2 by 2 equal to 3, applying midpoint formula, because this is the midpoint of AB. x1 plus x2 by 2 equal to 3. Similarly, y1 plus y2 upon 2 equals to 4. Yes. So this implies x1 plus x2 equal to 6, y1 plus y2 equals to 8. Yes. Similarly, for these 2 points, we'll get x2 plus x3 by 2 equal to 8, that means 16, and y2 plus y3 by 2 equal to 9, that means 18. And for A and C, x1 plus x3 by 2 equal to 6, that means 12, and y1 plus y3 by 2 equal to 7, that means 14. Yes. So we are getting 3 equations for x, and for y is 3 equations. Now if we add these 3 equations, we will get twice of x1 plus x2 plus x3. How much? It is 34. Yes. So x1 plus x2 plus x3 is coming 17. Yes. Similarly, adding these 3 equations, we are getting twice of y1 plus y2 plus y3. How much? Adding here 26, that means 40. So y1 plus y2 plus y3 coming 20. Yes. Now from this equation, if I subtract 1 by 1 all these results, we'll get x1, x2, x3. So from this x1 plus x2 subtracting, we are getting x3 values 17 minus 6, 11. x2 plus x3 subtracting, will get x1, 17 minus 16, 1. And from this x1 plus x3 subtracting, we'll get x2, 17 minus 12 is 5. Yes, we got x1, x2, x3. Same technique will apply here. From this y1 plus y2 subtracting, we are getting y3 result 20 minus 8, that is 12. Subtracting y2 plus y3, will get y1 result 20 minus 18, that is 2. And subtracting y1 plus y3 result, we'll get y2 value, that is 20 minus 14 is 6. Is it clear? So coordinates of A, we have taken x1 comma y1, that is 1 comma 2. This is the coordinates of A. Coordinates of B, I have taken x2 y2, so 5 comma 6. Yes. And coordinates of C, x3 comma y3, that is 11 comma 12. These are the coordinates of 3 vertices. Yes. We can verify our answer is right or wrong. See here, 5 plus 1 by 2, that is 6 by 2, 3, and 6 plus 2 by 2, that is 8 by 2, that is 4. Yes, matching. That means these 2 vertices are right. Similarly, we can check this vertices also. Yes or no? But now I'll show the shortcut trick without all these calculations. We can say the vertices of ABC directly. How? Very simple technique. When we have to find the coordinates of A, add the abscissa part of these 2 points and subtract the abscissa part of this part. That means 3 plus 6, 9. 9 minus 8 is 1. Similarly for Y, 4 plus 7, 11. 11 minus 9 is 2. See how nicely we are getting. Now for B, what will do? Now abscissa part of these 2 points, that means 8 plus 3, 11. 11 minus 6 is 5. And for Y, 4 plus 9, 13. 13 minus 7 is 6. We are getting the coordinates of B. Same thing for C, 6 plus 8, 14. 14 minus 3, that is 11. And 9 plus 7, 16. 16 minus 4 is 12. So without any calculation, we can say the vertices of 3 coordinates applying this short trick. Is it clear? I think you enjoyed this. Fine. Now I'll solve example number 10. Find the lengths of the medians of the triangle with vertices A, B, C. The coordinates of A, B, C given. We have to find the lengths of medians. So I'm drawing one triangle ABC. Say ABC is a triangle. We know the coordinates of A, say 1, 0, coordinates of B given 3, 6, and coordinates of C given 8, 2. We have to find the length of medians. What is median? If you join the midpoint of one side to the opposite vertex, that will give the median. So AD is the median here. Similarly, BE is the median for AC, and CF is the median in respect of AB. Is it clear? So we have to find the length of these 3 medians. First we have to find the coordinates of D. D is the midpoint of BC. So coordinates of D will be 8 plus 3, 11 upon 2, and 2 plus 6, 8 upon 2, that is 4. Coordinates of E is coming 1 plus 8, that is 9 by 2, and 0 plus 2 by 2, that is 1. Yes. And coordinates of F, 3 plus 1, that is 4 by 2, that is 2, and 0 plus 6 by 2, that is 3. Yes or no? 3 plus 1, that is 4 by 2, that is 2, and 6 plus 0 by 2, that is 3. So we got the coordinates of midpoints. Now we have to find the lengths of 3 medians. So first median AD, root over of 11 by 2 minus 1 whole square. 11 by 2 minus 1 whole square plus 4 minus 0 whole square. Is it clear? 11 by 2 minus 1 whole square plus 4 minus 0 whole square. So that means 11 by 2 minus 1 means 9 by 2 whole square. 81 by 4. And here 4 square 16. So how much? 81 plus 64 upon 4, the whole root, and it is how much? 145 upon 4. Yes or no? Now root over 145 by 4, simplification, how much? Is cancelled by 4, 2, that is 29 into 5, but not perfect square. That means we can leave answer like this, half of root over of 145. This is the length of median AD. Is it clear? Understood? Now length of median BE. BE, that is 9 by 2 minus root over of 9 by 2 minus 3 whole square plus 1 minus 6 whole square. Yes. This result, how much? 9 by 2 minus 3, that is 9 minus 6. 3 by 2 whole square, that is 9 by 4, plus 1 minus 6 is minus 5 whole square, that is 25. So length of this median 100 plus 9, 109 by 4, so we will get root over of 109, half of that, half into root over of 109. Is it clear? Here half into root over of 145. So this is the length of median AD and B. Now length of median CF. CF is, we can write here CF. What is the result for CF? 8 minus 2, that is 6 square, 36, and 2 minus 3, that is minus 1 whole square, 1. So root over of 37 is the length of median CF. Is it clear? I think this part is clear. Okay. So this is last sum, and I am ending my class here. Okay students, still if you have any problem, you can contact me through my mail ID, that is manojj@tigps.in. If you have any doubt, you can contact me through this mail ID. Thank you students, have a nice day, bye.